All right, this is Honors Algebra 2 Pre-Calc. We're doing 4.5 in Algebra 2, which is Gaussian elimination for matrices. And this is our last video in this section and also in Chapter 4. So we're going to talk about how you can use a calculator to skip to the end of reduced row echelon form and give you the answer. So we're going to walk through this, and this is particularly useful if you get into any of the weird situations where something is inconsistent, meaning has no solution, or is consistent dependent, meaning has infinite solutions. So let's walk through this. So we're going to enter our augmented matrix as A. Okay, so just to be clear, what that means is that if my, so let's say that my matrix has like these three spots, right? These three spots, those are my three variables, and then I've got my little colons, and I've got my three constants, right? I'm going to enter A as a 3 by 4, because even though I know that it's an augmented matrix, like I know that it's augmented, I know that this is the thing that we want to reduce, but I'm going to enter A as a 3 by 4, okay? And then what we're going to do is we're going to go to matrix and calc, and we're going to pick RREF, which stands for reduced row echelon form. And I'm going to be able to make the calculator jump this thing right to reduced row echelon form, and then once I have that, we're going to walk through some cases of those weird situations. So let's go ahead and talk about example 4. So example 4 is actually example 2 in your textbook. So I already took the luxury of putting this into my calculator. So if you did this in reduced row echelon form, right, this is good, or I'm sorry, if you did this in augmented matrix form, right, it's going to look like this. 3, negative 4, 1, negative 1, 5, negative 8, negative 3, and 11, right? So when I put into matrix A, I'm going to make matrix A 3 by 4 matrix. So let's go ahead and, I already did that because I was lazy and did it ahead of time. Plus, in most of these videos, I've shown you how to enter stuff. So you can see that those are the first three, so those are the first three columns that I'm supposed to have in my A. And then if I go down here, I can scroll over and show you that the last column also matches. So I'm going to quit out of that. So I now have A, right? So once I have that, what I'm going to do is I'm going to go back to matrix. Okay, so I'm going to do that second. I'm going to go back to matrix. Remember that we get to the matrix button by doing second and the X inverse button, right? But then I'm specifically going to go over to where it says calc. Okay, so let's go ahead and walk through that. So I'm going to go ahead and go second matrix. Or sorry, not calc. It's math. My bad. Take that back. It's math. Sorry. All right. So math. I take it back. So I go over to math, and now I'm going to scroll down until I find reduced row echelon form. And there it is, right? So I'm going to pick that. I want reduced row echelon form for A. So I'm going to go back to matrix. I'm going to pick A, right? And then I'm going to hit enter. So now let's go ahead and take a quick picture of what this looks like. And then we're going to walk through the actual meaning of this now that we have a picture of what it looks like. Okay, so let's think about what this means in the context of this problem, right? So what this means in the context of this problem is that I now have essentially, I have an equation that literally just says 0 equals 0, right? Which is true, right? That's true, right? But what that means is when all of our variables disappear and we get a true statement, what we have is a situation where we're looking at a consistent dependent system. So this is consistent dependent. Okay, consistent dependent, which means that there's going to be infinite solutions of some form. So there's going to be infinite solutions of the form, and then we're going to talk about what that form looks like in a sec. So we're going to leave 3 spots for x, y, and z. So because this is the z, so see how we have, currently we have 2 other equations. We have x plus 5z equals negative 13, and we have y plus 3.5z equals negative 9.5. So what I want you to notice is both of these equations are in terms of y, or I'm sorry, or in terms of z rather, right? Sorry, brain. Okay, so if I solve the first equation for x, I get that x is negative 5z minus 13, and I get that y is negative 3.5z minus 9.5, and I get that z could be any number because there is no equation for just z, right? They're both in terms of z, right? They both include z, but there's no equation for z. So one way to write this would be to just put the letter z in for z, right? So I'm just going to call, but I'm going to do what I've done every other time and call z the letter a. So this would be a, and then y would be negative 3.5a minus 9.5, right? And x would be negative 5a minus 13. So to pick the laziest possible version of this answer, if I picked 0 for z, so like one answer to this would be if I pick z is 0, which is the laziest possible version, I'd get negative 13, negative 9.5, and 0. And that's one possible answer. But I could pick other answers, right? I could pick the answer where z is 1, right? And if I picked the answer where z is 1, right? So, or if I picked something like z is 1, it would look like a negative 18, a negative 13, and a 1, right? So again, but you don't want to say individual answers. What you want to say is that this is consistent, dependent, and there are infinite answers, right? But notice that we have an equation for x and z, we have an equation for y and z, but we don't have a way to define z because that last row is gone, okay? Cool, so let's do the other weird example. So we did example, that was example 4. We're gonna do an example 5. Oh, I lied, I gave a P4 for you. And then, so you're gonna try the same idea with P4. Again, this is not one you're suggested to do by hand. You could do it by hand if you want, but I'm not gonna suggest that you do that, right? I'm gonna suggest that you put A into your calculator, right? I'm gonna suggest that your matrix A in your calculator is the augmented matrix 2, 3, negative 1, negative 2, 1, 2, 2, 8, 5, 9, 5, 22, right? So, and then you're going to do reduced row echelon form of A, and you're going to get an answer, and then we're going to proceed from there. So you can pause me if you want. I'm going to go ahead and go to second matrix. I'm going to go to edit. I'm going to edit my A, which is already the correct dimensions. 2, 3, negative 1, negative 2, 1. Oops, sorry, my bad. 1, 2, 2, 8, 5, 9, 5, 22. Right, and then you just double check that it lines up right. My last row should be negative 2, 8, 22, which it is. The next, or my last column rather, my second to last column should be negative 1, 2, 5. That's right. 3, 2, 9, and let's just double check that my first column is 2, 1, 5. All right. Yep. All right, cool. So we're all good. So I'm going to quit out of that. And then I don't even have to go pull up reduce row echelon form again. Remember that trick that if you want the same action, you could just hit second enter and hit enter, and there you go. All right, so now we're in a similar situation, right? When we do this, we're in a similar situation. If we drag this guy right in here, right, my reduced row echelon form for A. So what this tells me is that z could be any number, right? But y plus 5z is apparently an 18. Meaning that y is negative 5z plus 18, right? And x minus 8z is a negative 28, meaning that x is apparently an 8z minus 28, right? So I have x in terms of z, I have y in terms of z, and z, 0 equals 0 is true. It's not a false statement. We'll see somewhere it is. So what that means is that my answer is consistent, dependent, right? And so that means I have infinite solutions of the form. And in this case, the one that I don't have any information on is z. So I'm going to say A, or I'm just going to say z equals any number. I'm just going to call it A. So then y should be negative 5a plus 18, which I'm kind of squeezing in there. And x should be 8a minus 28. Right? And again, if you want to pick an easy answer, if you plugged in A as 0, you'd get negative 28, positive 18, 0. If you plugged in A as 1, you'd get a negative 20, a positive 13, and a 1, right? There's infinite solutions of that form, okay? So there's infinite solutions of this form. All right, cool. Let's go ahead and walk through an E5. Same idea, right? I'm going to enter my matrix A as the augmented matrix, 2, 6, negative 4, 1. 1, 3, negative 2, 4. That's a 1. I just did a bad job at it. 2, 1, negative 3, negative 7. Oh, interesting side note that I didn't mention, but if you're doing those reduced row echelon problems like Gaussian elimination by hand and you're really stressed about getting a fraction early on and you think, hey, that's weird. Hogan said usually they're not fractions, but I got a 7th. Sometimes the answer is 1/7, and that's fine. But if you're not sure, you could just make your calculator do reduced row echelon form first, see if the answers are nice, happy numbers, and then kind of work from there. If you notice that the answers are all disgusting fractions and decimals, then don't panic when you get a disgusting fraction or a decimal. It's totally fine to use a calculator to help with what you're already working on, to make sure that you're not going crazy if you get an ugly number. In fact, that's a good thing, right? You don't want to go down the rabbit hole of having really ugly decimals or ugly fractions and then find out that it's all because you added wrong in one random step, right? It's much better to say, hey, I skipped to the end, I found what the answers are, now let me go back and do the problem, and if I get a weird fraction somewhere in the middle, I'll stop and figure out what I did wrong. Or if I get a weird fraction in the middle, I know the answer is a weird fraction, so we're cool, and I'll just keep suffering through it, right? It's not a bad idea to don't go full steam ahead on a problem. If you start to hit something that seems weird, stop a beat, take a breath, and see if you made a silly mistake or if the problem really is that hard. Okay, so anyway, we're going to do reduced row echelon form for A, right? And we're going to do that in the calculator, so I'm going to go ahead and pull the calculator back up, right? So when we do this in our calculator, we're going to have, I'm going to go back to second matrix, and really my entire job is to go over and edit A because I already did reduced row echelon form. So 2, 6, -4, 1, 1, 3, -2, 4, 2, 1, -3, -7. All right, so let's double check that they are correct, right? My last column is 1, 4, -7. The next column over is -4, -2, -3. The next column over is 6, 3, 1. Sorry, there we go. All right, and the first column is 2, 1, 2. Perfect. Okay, so I quit out of this, and I can hit enter again, and there's my reduced row echelon form. Now, this one, something different happens. Okay, so this is actually the easier problem, to be clear. Okay, so what I want us to do is focus on the bottom row. The bottom row is a lie. The bottom row says 0 equals 1 because it's saying no z or no x's plus no y's plus no z's equals 1. That's a lie. You don't have to do any more math. This is inconsistent and there is no solution. Yay! No solution. End of story, right? That's a lie. 0 on this side, right? Because remember, this is where your equal signs are, right? These are where that's where the augmented matrix has its dots, right? So all those colons there say that those are the equal signs. This is saying 0 equals 1. That's a lie. All of computer science is built on that concept that 0 and 1 are not the same. So you're done. All right, so let's try a P5 the same way, right? So again, when you go to put your A in, right, your augmented matrix is going to be 4, -4, -3, 2, 4. Be careful, the 0's there for the Y. 3, 3. 0, 4, 6, and 3, right? So when you go to put that in, you're going to do your reduced row echelon form of A. You're going to see what happens, right? So let's go ahead and do that, right? So I go second matrix, go over to edit, I pick A. 4, -4, -3, 2, 4, 0, 3, 3, 0, 4, 6, 3. Cool. Okay, so let's double check. My column, last column should be 2, 3, 3, -3, 3, 6, -4, 0, 4. And the first one's 4, 4, 0. So we quit out of this, hit enter again. All right, there we have it, right? So same situation, right? I look here and I say, wait a second, it doesn't matter what the rest says because that is a big old lie. That says 0 equals 1, right? Because that's saying 0x plus 0y plus 0z, which by the way is a whole bunch of 0 equals 1. That's a lie. So this is inconsistent and there is no solution. And it doesn't matter what the other two say because that last equation is a lie, which means the whole thing is inconsistent. No solution. Cool. So let's talk about the very last little bit of this. Okay, so why am I making you do this? So, and you can turn off the video now if you don't want to hear me explain. So, good question. Mathematically, this is the only way at the level you're at right now to tell if a system with more than 2 variables is consistent, dependent, or inconsistent, like we just saw in example 4 and example 5 and P4 and P5. So, at this level, that's your option. So with a 2-variable system, you could figure that out in a number of other ways, because if it's a 2-variable system, you could graph it and see that they are the same line or they are parallel lines. But right now, with 3 variables, this is what you've got. Also, being able to logic through something that's difficult is important, right? Not the concept itself. I'm not saying that Gaussian elimination is going to turn out to be the thing that's the most important in the whole world, right? I'm not saying that you're ever going to be in like a cage with a man-eating tiger and the combination to the cage is going to be resolved by Gaussian elimination and boom, you saved your life. I'm not saying that. That's not going to happen. At least it's very unlikely. If it does happen to you, I'm very, very sorry, and hopefully you remember these videos. So it's not that. It's being able to reason through something difficult. So next bit, being able to take prior knowledge, like how we work with equations, and apply them to something new, like augmented matrices, is more important as a life skill than math is, right? Being able to take things that have happened to you in your life previously or skills that you've learned in a different situation and find a way to apply a modified version of those skills in the current situation is a super dope thing. So that's why. Next, because getting the logic behind the math is more important than the math itself sometimes. Sometimes you're actually doing this kind of stuff to train your brain to conceptualize abstract, complicated things. And challenging yourself is important. Next reason, next year in AP/AB, most of you will remember that you hated this. You're also going to remember you hated 9.4 in pre-calc mathematical induction. And then when you're in BC, you're going to remember that too. You'll also remember hating a bunch of things from AB. Hating things doesn't make you bad at math or stupid or anything like that, right? It's okay to hate it. Every kid that has sat through AB and BC has gone through these things when they were in Honors Algebra 2 pre-calc, and they've hated them too. Some of them liked them more than others. Some of them thought, oh, this is kind of a fun challenge, but like I'm really glad this section's over because that homework was the worst, right? Or whatever, right? It's okay to hate this. It's okay to think I'm a monster. It's fine. But it's not okay to quit because something's hard, right? That's the thing here. You have to push through and try to get the logic behind it. And if you don't get the logic, it's not the end of the world. But the way you get better at comprehending things like this, the way you get better at pushing yourself is to push yourself, is to fail a little bit, to try it and get frustrated, and that's okay, right? And the last bit, and I've mentioned this in another video, don't panic. Even though I ask you to do this on an assessment, for this specific chapter, it's worth less than a letter grade on that assessment, right? Like if you can set up the augmented matrix and you can use your calculator to skip to the end, you're going to get most of the points on the problem, and then I throw you some points for the middle parts to see if you can do it. It's not designed to make you feel like you're failing. It's not designed to cost you a letter grade. If you were going to get an A, you'll probably still get an A. If you were going to get a B, you'll probably still get a B. It's fine. Like, it's not a big deal. It's a few points at most. But I do want you to try to push yourselves. So if you hated this video and you've hated this section, I'm sorry, but it's okay. So did everybody else that came before you, and they made it through just fine. Okay? This is the end of chapter 4.